A function is something that connects an input to an output with a rule. To find the value of the function, i.e. the output number f of x, or you could also name this y or whatever, but anyway, you end up with a rule that says something is equal to some rule applied to some other number. So the output is you take the input and you do something to it. That's what a function does. You substitute the input you want in and you evaluate to get the function value at that input. So the function value at 5, if function of x is equal to 2 plus 3x, would be, well, you substitute 5 in for the x, and that gives you 17. Yeah, it's sometimes found with function tables. This is something that you usually stop bothering with pretty quickly, but you still have to know this sort of thing exists, therefore let's do this. So, function table for f of x equals 2x plus 4. Well, negative 1, 0, 1, and 2 are usually pretty good bets for your inputs. Or 0, 1, 2, 3, something like that. Rule 2x plus 4. Okay, so 2 times negative 1 plus 4 is going to be equal to 2. 2 times 0 plus 4 is going to be 4. And 2 times 1 plus 4 is going to be 6. 2 times 2 plus 4 is going to be 8. Well, let's do some exercises. So f of 1, if f of x is equal to x plus 3, well, we substitute in and we get f of 1 is equal to 1 plus 3 equals 4. F of 6 is if f of x equals 2x, so the function of x is equal to double the value of x, or x times 2. Well, then that tells us that f of 6 is equal to 2 times 6, which is equal to 12. F of 4 is equal to, once again, we just substitute 4 in for x, and we get 5 times 4, which is 20, minus 4, 16. Now f of 9, well, we just substitute in, just like before. So f of 9 is equal to negative 3 times 9 plus 10. So in other words, negative 27 plus 10, which is negative 17. F of negative 2, yeah, we just substitute right in again, which gives us 4 times negative 2 minus 1. And that gives us negative 8 minus 1, negative 9. All right. What about f of negative 5? If f of x equals negative 2x plus 8, we just substitute in. Negative 2 times negative 5 plus 8. In other words, 10 plus 8, so 18. Okay, let's do some function tables. Well, if we have x equals negative 1 and we apply this to f of x equals x minus 10, we would have negative 1 minus 10 here. And that would be negative 11. As you can probably tell, it's pretty quick that for most simplistic functions, you can omit this middle column in a function table and you would just have like x, y, or f of x, and just go with it. Yeah, okay, so for now though, we gotta work out the basics one step at a time, right? So you just substitute x in, and then you simplify. I mean, this is what you would do on just in an equation format, but usually function tables just look like this. Okay, so 2 times -3 plus 6 gives you 0. 2 times -1 plus 6 equals 4. 2 times 2 plus 6 equals 10. 2 times 4 plus 6 equals 14. 2 minus 3x, that's a 2 minus, well, here it was x equals -2. So -2. -3 times -2 is, or rather, minus 3 times -2. Well, that's minus -6, or plus 6. Therefore, this would be 8. 2 minus 3 times 0 is going to be equal to 2. 2 minus 3 times 3 is going to be 2 minus 9, or -7. 2 minus 3 times 4 is going to be 2 minus 12, which is -10. What happens when we decide to do these functions that we did above, where you have a constant multiplier of x and then plus or minus some constant, and we decide to plot this on a graph with f of x being the vertical column and the horizontal axis is x? Well, you end up with a linear function because the graph of the solutions form a straight line. And consider graphing y equals x minus 2, for example. Our first step would be to choose some values for x and make a table, a function table, and this would give us some points for x and y. You will very quickly find that this column here of the coordinates is generally not considered necessary very, very quickly. Like, we get rid of it pretty fast. Because, hey, you have an x and you have a y. The x and y on the same row correspond to a point. Like, this is not exactly mind-blowing. Your step 2 is to graph each of the ordered pairs on a coordinate plane, and then you draw a line that passes through the points. The line is a graph of the linear function. Why is it linear? Well, that's because the slope is constant. We'll get to slope shortly. The slope is how much the y increases with every increase in x, or how much y decreases with every decrease in x. Alright, let's do some exercises. Complete the function table, then graph. Okay, y equals x plus 3. Okay, we're looking at x equals -2 first, so that's -2 plus 3. Y equals 1. X equals 0, that's 0 plus 3. And y equals 3. X equals 1, that leaves us with 1 plus 3. And y equals 4. X equals 2, that's 2 plus 3. And y equals 5. And then that's x, y. The coordinates would be -2, 1, 0, 3, 1, 4, and 2, 5. And if we plotted these, we would end up with 2, 5, 1, 4, 0, 3, -2, 1. So, this is -2, this is 2. Labeling the axes is important. Now here you are about to witness why drawing your lines without a ruler is a terrible idea and you should never ever 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 try it. Watch. If you think that this is a straight line, I have a bridge to sell you. This is not what it's supposed to look like when you plot a linear function. Well, okay, if you really don't have a straight edge, just improvise, but even then you should like use the light pencil stroke technique with repeated shadings to make your line. Don't try to draw lines without rulers if you can at all help it. Even like the edge of your pencil case, if it's a hard straight edge, is better than this. Alright, let's replace that with a straight line. There, now isn't that a lot better? It's actually straight now. Okay, let's graph a few more functions. Function tables are something that you will very quickly learn to get rid of altogether for most linear functions. Just a word of warning, guys. Y equals 3x plus 2. Well, what happens when x equals 0? Oh, that's going to be equal to 2. Okay, 3x. That means that when x equals 1, this is going to go up by 3. So up here, then that holds. So this is negative 2. This is 2, 2. Decide where to put your labels based on where you expect the line to pass. This is important. We'll plot the points and then we will draw the straight lines. Okay, 2 minus x. Well, when x equals 0, this is 2. When x equals 2, this is 0. Actually, you only need 2 points because this is linear. How do we know it's linear? It's because it's not, say, x squared or square root of x or something. We have a constant multiple of x. So the change in y for every change in x is going to stay the same. 2, 2. This is going to slope downward because it's y equals 2 minus x. As x gets bigger, y gets smaller. 3x minus 1. Well then, it's going to go like this. And this is 2, 2. Sometimes you don't even need to mark out the negative axis. You just need to make sure that everybody knows how much one grid means on each of the axes. Okay, now let's apply a ruler to actually draw the lines straight. There, aren't these straight lines nice? So yeah, as you can see, with experience, you will very quickly stop producing function tables for linear functions and just plug in a couple points and then draw a line through them. Of course, this favors people who are good at mental math, so please do practice. Okay? If needed, produce a few points via a quick table, 2 columns, three rows, counting the title, and that should actually be enough, as long as you don't accidentally set your x's to be equal. Okay, slope. Slope measures the steepness of a line. In other words, for every amount it goes across, how much does it go up or down? So the slope of the line passing through points x1, y1 and x2, y2 is the ratio of difference in y coordinates to the corresponding difference in x coordinate. Dude, do you know how this was taught back in my day? This was rise over run. Rise is how much it went up or down. Run is how much it went across. Yeah, that's probably a little quicker to remember than the difference in the y-coordinates divided by the corresponding difference in the x-coordinates, even though it means exactly the same thing. Okay, so as an equation, it's given by difference in y-coordinates divided by difference in x-coordinates. Make sure that you keep the order the same, so that you don't end up accidentally going y2 minus y1 over x1 minus... No. It's 2 first or 1 first. Why? Well, if we have y1 minus y2 instead, it would be negative of y2 minus y1. If we flip the bottom around to as well, then it would also be negative. Result, no difference. Now, let's find the slope of the line that passes through point A, negative 1, and point B, which is 2, 3. The slope is m equals rise over run, or y2, well, yb minus ya over xb minus xa. Feel free to actually write rise over run a few times, okay? Like when you're just getting started doing these problems, be not afraid of writing a bit more than I would. Because, well, there is in fact a difference gap, okay? Be not afraid and be not ashamed of doing whatever you have to arrive at the correct answer. Less writing and a wrong answer, well, that's basically worthless compared to writing a little bit more and actually getting it right. So yb is 3 minus ya, which is negative 1, over xb, which is 2, minus xa, which is negative 1. So this would be 4 over 3. And we look at the graph. Does this make sense? Oh, for 3 grids we went across, positive 3 grids, we end up going up 4 grids. So rise is 4 versus run is 3. Yep, okay. Now example 2. Find the slope of the line that passes through C and D. So we're looking at slope equals rise over run. That means yd minus yc over xd minus xc, which gives us negative 2 minus 4 over 3 minus 1. That's negative 6 over 2, which is negative 3. Let's see, does this make sense? Oh, for 2 grids we went over, positive 2 grids, run, we had a rise of negative 6 grids. So for every 1 grid we went over, we went down 3. Okay, let's do some exercises. So, find the slope of the line that passes through each pair of points. And that means m equals rise, which is yb minus ya, over run, which is xb minus xa. And that's going to be 4 minus 1 over 3 minus 0, which gives us 3 over 3, very convenient, which is, of course, 1. Second question, second exercise, we have slope is equal to yd minus yc over xd minus xc. And this is going to be 2 minus negative 2 over 3 minus 1. And that's going to be 4 over 2, which is 2. Now for E, 4, negative 4, and F, 2, 2, we would have slope is equal to yf minus ye over xf minus xe, which would give us 2 minus ye is negative 4, xf is 2 minus 4, and that's going to be 2 plus 4, which is 6 over negative 2, which is negative 3 for the slope. As you can see, all you really have to do to find the slope is have 2 points along the line, and you plug them into slope equals rise over run. So rise here is 3 minus 1. Like at some point you probably end up reaching the point where you sometimes just omit the original expression step. Now, depending on teacher, you might not be allowed to do this. Okay, this is important. Usually in algebra, you're supposed to keep the original step before substituting in. Depends entirely on how much your teachers allow you to get away with. Be careful. So, yj minus yi over xj minus xi. It's very unusual that I was actually used as a letter for a point, because points are represented by capital letters. Because, well, usually we omit I and O from math for hopefully obvious reasons, i.e. because they look too much like 1 and 0. O, on the other hand, we do use O for the origin, which is 0, 0 on a Cartesian grid, but, well, otherwise, no. So yj was 4 minus yi, which is 3, over xj, which is 2, minus xi, which is 4. That leaves us with 1 over negative 2, so negative 1/2. Now, k and l, we would be looking at yl minus yk. Oh wait, no, it's capital K. Okay. Over xl minus xk. And this would leave us at 4 minus 4 over 5 minus negative 4. The reason why the two x values can't be the same is because you would end up with dividing by 0, which is undefined. If you have a slope of undefined, it's a vertical line, and the equation of that line is x equals something, some value, to set where that vertical line is along the x-axis. On the other hand, if your y values are the same, you end up with a slope of 0, which means that it is a flat line. And the equation is going to be y equals some value, some constant value. If you have a constant ratio between two variable quantities, in other words, if the slope is the same, so it's constant, and they start at 0, 0, then this is called a direct variation. So the ratio between the two would always be equal to the slope. The distance a bicycle travels varies directly with the number of rotations its tires make. Yeah, you would hope so. Otherwise, well, I mean, either you started counting rotations sometime after the bicycle started moving, because, well, one circumference of its wheels should always be in contact with the ground, and where it's in contact, the wheel is stationary with respect to the ground. So if the wheel rolls forward one circumference, the bicycle should have moved forward by the same distance as one circumference of the wheel. Otherwise, either the bike is skidding, which you would generally not enjoy very much, or it's flying, which is generally slightly dangerous, or you just started counting the rotations a bit late. Don't try this. Like, at least if you want a direct variation, don't try this. So let's determine the distance as a bicycle travels for each rotation. The distance is given in inches. We're looking for the rate of change of distance with respect to number of rotations. So therefore, we're looking at a slope of 80 inches minus 0 over 1 rotation minus 0, which gives us 80 inches per rotation. Usually you will find that these rotations are given in revolutions. So it would be inches per rev, like REV. Now, let's say we're buying decks of trading cards for whatever reason. If there are 84 cards in 7 packages, how many cards are there in 12 packages? Well, how many cards are there per package, basically, is what is being asked. How many cards per pack? Well, we're looking for 84 divided by 7 is equal to 12 cards per pack. Therefore, 12 times 12 is equal to 144 cards in 12 packs. All right, exercises. Let's write expressions and solve the given situations. 4 friends bought movie tickets for $41. The next day, 7 friends bought movie tickets for $71.75. What is the price of 1 ticket? Okay. Let 1 ticket cost C. Okay? For C is $41. Therefore, C is equal to $10.25. Let's see if this works for 7. Well, 7 times 25 is 175. And 7 times 10 is 70. Okay, good. Yeah. The cost of each ticket is $10.25. What if there had been a constant admission cost, though, for the group? Well, then you would have 4C plus F equals 41, 7C plus F equals 71.75, and we would solve this as a system of equations, which we will get to shortly. Rick earns $24.75 in 3 hours. If the amount that he earns varies directly with the number of hours, how much would he earn in 20 hours? Well then, we know that f of x equals mx. F3 equals 24.75. Let f of x be earned in x hours. Okay. And M is pay per hour. M is pay per hour, or hourly rate. This means that f of 3 is equal to 3m. And that's 24.75 equals 3m. M equals $8.25 per hour. Hey, what do you do if you run out of space? Well, let me show you something. Most teachers are okay if you start new columns like this. Okay, this signifies that there's a new column. And if they're not used to this format, you can draw a little arrow like next column, and then a little arrow like this. Next column. Okay, how much would he earn in 20 hours? F20 is equal to 20m. It's equal to 20 times 8.25. 20 times 8 is going to be 160, and then times the 2.25 is going to be 5. So $165. Now, a bread recipe calls for 2½ cups of flour for 16 servings and 3 1/8 cup of flour for 20 servings. How much flour is required to make bread to serve 12? Guys, if this is direct variation, then you can take the difference between these, because 20 servings to 16 is minus 4, and then apply it again to get the 12. But we're not going to do that. Find flour per serving. And we would be looking at 2½ cups divided by 16 servings. That leaves us with 5/32 cups per serving. Okay, let's check to see if this works for the other one, to make sure that this is actually direct variation. 3 1/8, 3 times 8 is what, 24? So 25/8 divided by 20. Okay, first you divide by the 5, that leaves you 5/8 divided by 4. 5/8 divided by 4 is 5/32. Okay, good. Now you multiply to get 5/32 times 12 equals, you can cancel out a 4, 15/8 cups of flour for 12. We can write a linear equation in the form of y equals mx plus b. This has a slope m by telling you, oh, for every 1 that x increases, y increases by m. Okay, what's a b? The B is when x equals 0, what's the y value? Also known as what the y-intercept is, where the line meets the y-axis. The y-axis is at x equals 0. So this is called the slope-intercept form. Now state the slope and y-intercept of the graph of y equals x minus 3. Y equals x is going to have the slope of 1, because for every 1 that x increases, y increases by 1. And minus 3, you just shift the whole thing down 3. So, slope is still 1, and y-intercept is equal to negative 3. Now in example 2, graph y equals 2x plus 1 using the slope and y-intercept. You would start at x equals 0 and you get y equals 1. And then you would go right 1 and go up 2 because y equals 2x. So that's the slope. And then with those 2 points, you can just draw a straight line through them. Now let's do some exercises. State the slope and y-intercept of the graph of each equation. Well, here y equals x plus 1. The slope is the multiplier that's applied to the x, which is 1. Slope equals 1. And y-intercept, sometimes abbreviated like this, y-int, is equal to 1. Here, y equals 2x minus 4. The slope equals 2. And y-intercept is negative 4. Y equals 1/2 x minus 1. The slope is equal to 1/2. And the y-intercept is equal to, well, when x equals 0, y is negative 1. Okay, now let's graph some equations using the slopes and y-intercepts. So y equals 2x plus 2. Well, when x equals 0, this is going to be 2. And 2x, that means the slope is going to be 2. And then we will draw a line through these, which we will do shortly. Y equals x minus 1. Well, when x equals 0, this is going to be negative 1. And for every 1 that x increases, y is going to be increasing by 1. And y equals 1/2 x plus 2. Well, we start off at 2 when x is equal to 0. And for every 2 units that x increases, we're going to go up by 1. Now we should label our axes. The scaling is very important business, guys. Don't forget. Okay, now let's apply a ruler. Well, there we go. Nice straight lines. When we write systems of equations, that means we're writing several equations together. Now, these equations may cross. If they cross, like when we graph them, they may cross. If they cross, then this system of equations has solutions, or a solution at least. And, well, that means that the ordered pair satisfies each of the equations in the system. It's possible to make a system of equations with no solutions, such as, y equals x and y equals x plus 1. What happens when you draw them? You end up with 2 parallel lines which never cross. Yeah. What happens if you decide to use inequality symbols instead? Well, instead of a line, you end up with, it's bigger than this value. That means you either shade the entire part above the line, or smaller than this value, or you shade the entire part of the graph below the line. Let's say we have two students who took a mathematics quiz, and their combined score was 172, with student A's score 18 points higher than student B's score. Student A have A points and B have B points. The system of equations here would be student A's score was 18 points higher, which means that A is equal to B plus 18. And their combined score was 172, which tells us that A plus B is equal to 172. If we wanted to solve this system of equations, we would substitute in, and we would end up with, we would name this equation 1 and this is equation 2, and usually we would use a brace bracket to signify that they are the same system of equations. And we would say sub 1 into 2. And that would give us B plus 18 plus B is equal to 172. So that means 2B is equal to 154. And then we divide. So B is equal to 77. And then we would get sub into 1, and we would get A is equal to 77 plus 18, which is equal to 95. Hurrah. Yeah, this is the sort of thing you can do to solve a system of equations. You can also use elimination, but that's usually, say you have A plus B equals something, A plus 2B equals something. You can subtract the entire expression where you end up subtracting both sides. And you would end up with, say, just B equals something. However, we usually do that sort of stuff a little bit later. So let's write a system of equations or inequalities to represent each situation. In other words, we don't have to actually solve. But I'll show you how to solve it anyway. Let her have C CDs and D DVDs. Man, who even uses CDs anymore? Or DVDs for that matter, usually. Rare. Anyway, she has 24 more CDs than DVDs. Her CD number is 24 more than her DVD number, which means C equals D plus 24. And you know what? Line up the variables. We really don't care much for that, except that it says in standard form. Do you know what standard form means? That means you need to have all your variables on the left side in alphabetical order. That means C minus D is equal to 24. Okay, and what's the other expression? Oh, the total number of CDs and DVDs is 356. So C plus D is equal to 356. If we were to solve this, what I would do is number these off. Okay, this is me solving this. You add these expressions together, and what do you have on the left side? Oh, you have C minus D plus C plus D. The minus D and plus D cancel out, so you end up with 2C is equal to 24 plus 356. Okay, 376, 380. Okay, 380. C is equal to 190. And then you would solve for D by substitution. The first step that I did here is called elimination, because it eliminates one of the variables. Now let's say we want to make a system of equations for this next problem. Tina doesn't have the time to spend any more than 30 minutes total studying for math and history together. Let her study, or let Tina study math for m minutes, and history for h minutes. Okay, so she also wants to spend at least 5 more minutes studying for history than for math. That means history is greater than or equal to math plus 5. Now, because it says standard form, that's h minus m greater than or equal to 5. And the total is any more than 30 minutes total. That means up to and including 30 minutes. So h plus m is smaller than or equal to 30 minutes. Yeah, this is your system of inequalities here. Now, 62 people went to the movies. The price for adults was $6 and the price for students was $4. The total cost for the group was $290. Okay, so let A adults and S students have gone. Okay, that leaves us with A plus S equals 62 and 6A plus 4S is equal to 290. Yeah, if I had to solve this, I would do... This is your system of equations, by the way. Like, this is it for what the question required. But I'm going to show you how to solve this. 2 minus 4 times 1. That gets rid of the 4s right away. And we would have 2a equals 290 minus 4 times 62 is going to be 248. So 2a is equal to 42. A is equal to 21. All right then. What about S? Well, S you would sub back into 1. To 1. Equation 1. Because equation 2 just makes it unnecessarily awkward. And you would end up with 21 plus S equals 62. Therefore, S equals 41. Well, this doesn't seem to be a field trip because there were a bit too many adults. But perhaps it was a field trip plus some other adults who are unrelated. Well then. Problem solving investigation. Use a graph. Let's look at this graph. which shows the results of a survey of teachers' ages and grade levels taught at school. Do the oldest teachers teach the highest grade level? Well, the grade level taught is the highest grade level is 12. There doesn't seem to be any teachers at 12, but well, whatever. The point is, do the oldest teachers here, which we can see is up here, all generally teach the highest grade levels? Like, are they older teachers tend to be clumped toward higher grade levels, younger teachers tend to be clumped toward lower grade levels? I would say no. Like any correlation here that you can find, yes, you can in fact find a linear regression here. You can find a correlation, but it would be so weak as to be irrelevant. No. Older teachers are roughly randomly. Now, it might not look perfectly random because there's no points around here-ish except that one. But one of the telltale signs that a random series of heads and tails were generated by a human instead of a computer is a lack of long chains of heads or tails. Because real randomness can sometimes provide you with some pretty funny gaps in the information generated. Or rather, the information gathered after the randomness occurred. Okay, this graph shows the results of a survey of students' favorite sports. How many students were surveyed? Being able to read graphs is an important part of being able to deal with functions. Scatterplots, you can do linear regressions, which are a type of function, but that's mostly saved for later for data management. And here we have 34 plus 27 plus 39, which is equal to 100 students surveyed. Yeah, that was straightforward. So, let's use the graph below. Each point on the graph represents one person in a group that is training for a long-distance bicycle ride. The point shows the number of miles that person cycles each day and the number of weeks that person has been in training. What is the highest number of miles bicycled each day by any person in the group? How many weeks was this person in training? The highest number of miles bicycled was 47.5-ish, it looks like. 47.5 miles. And they were training for 10.5 weeks. 10.5 weeks. Does the number of miles bicycled each day increase as the number of weeks in training increases? I would say yes. There's not that much data to the sides compared to in the middle trend, which means that there is a weakly positive correlation. The correlation here is very weak, but it seems plausible, and it looks plausible on the graph, and it seems to make sense. Very weak positive correlation. So correlation is an association of how one value behaves versus another value. It can be positive, it can be negative, or it can be some sort of complex shape. Well, continuing in our dealings with scatterplots, when you graph two sets of data as ordered pairs, you end up with a scatterplot. The pattern of the data points determines the relationship between the two sets of data. If the data points generally trend upward as the other value increases, the horizontal axis increases in value, then that shows a positive relationship. If it generally trends downwards, that shows a negative relationship. If there's no clear pattern, then there is no relationship. Technically speaking, you can probably still do a linear regression and end up with some rather very, very modest correlation value. But in reality, no, don't bother with very weak associations most of the time. Really. Now explain whether these scatter plots show a positive, negative, or no relationship. Miles driven and gallons of gas used. This shows a positive relationship because as the miles driven increases, the gallons of gas used also increase. Intuitively, this makes sense because going somewhere has a cost, and that cost is fuel. Yes, even walking, because that costs energy that comes in the form of food. The number of minutes a candle burns and the candle's height, yeah, this is negatively correlated. The longer the candle burns, the shorter the candle becomes, because it burned up. Okay, or burned down, I guess. Etymology reason problems. Anyway, this is negatively correlated. Let's look at some exercises. Explain whether the scatter plot of the data for the following will show a positive, negative, or no relationship. A student's age versus a student's grade level in school. Generally speaking, older students are in higher grade levels. So this is going to show a positive relationship. The number of words written and the amount of ink remaining in a pen, well, as you write words, you use up the ink. Different words will use different amounts of ink, but in general, the more words you write, the less ink remaining, so this is a negative. Negative relationships are where when one variable increases, the other variable decreases. So they trend in opposite directions. Square feet of floor space and the cost of carpet for the entire floor. Well, guess what, guys? Carpet is priced per area, generally, when you're installing large amounts of carpet. So, that means that the bigger the floor space, the more expensive the carpet. The higher the cost. This is going to be positive. A person's height and the number of siblings the person has. Since when did how tall somebody was have any relationship with how many siblings they have? No. No relationship. I mean, if this question was asking a person's adult height and the number of siblings they have, there would in fact be a weakly positive correlation. Why? Well, because being big and strong is attractive, and they probably inherited that height from their parents, which means that they are more likely to have more siblings. But this is going into like ancient anthropology, which we're not doing here. The length of time for a shower and the amount of hot water remaining, well, the longer you spend showering, the more hot water you use up. So the less is left. That means this is going to be a negative relationship. Please apply common sense and don't shoehorn into, say, some sort of archaeology thought experiment or something. Yeah. Number of sides of a polygon and the area of the polygon. Okay. Draws tiny square, draws big square. How does the number of sides of the polygon possibly affect the area? I mean, if you said number of sides of polygon inscribed in a circle, in the same circle, sure. Like if you make a circle and you fit a triangle in it, it's not going to take up as much area as, say, fitting a square in it, or a pentagon, or a hexagon. But just number of sides and the area of the polygon in general? No, you can have a huge triangle, you can have a puny, well, say 50-sided shape, which kind of looks like a circle when it's small enough. Yeah. No relationship. Okay. Well, that's actually it for this chapter. We covered functions somewhat, and we discussed some systems of equations and inequalities, and we talked about scatterplots, which are what happen when you plot a bunch of data points as ordered pairs. An ordered pair is this. This is distinct from this. Basically, if you have a coordinate grid, a point is an ordered pair. A line is an equation. And an area, well, that's an inequality bounded by the line that defines the area. Or lines that define the area. Okay, well, that's it for this section. We'll see each other again later.